Hi, my name is Julia, and I'll be presenting a problem for Physics 114 about projectile motion. So the problem that I chose is a catapult crew is prepared to launch a rock with a speed of 40 meters per second at an angle of 50 degrees above the horizontal toward a cliff that is 56 meters away. An enemy on the top of the cliff, who is 80 meters above the level of the catapult, is about to drop a leather satchel, which is weighted with some rocks containing an important message in a glass jar. The catapult crew needs to have the rock hit the satchel to destroy the message. When the spotter sees the satchel being released, how much time should then elapse before he tells the crew to launch? The diagram on the left shows a diagram for the problem itself for you to better understand it. Now, since the velocity is at an angle, there's a diagram on the right that shows how the velocity is then broken down. We will use a diagram in the next slide. Since projectiles have velocities that are occurring in a vertical direction and horizontal direction, the horizontal velocity would be the velocity based on x, and the vertical would be based on y. In order to begin this problem, we need to split up the velocity into horizontal velocity and vertical velocity. To do this, we will need to implement trigonometric knowledge, knowing that in this case, sine solves in terms of y and cosine solves in terms of x. The given velocity of the projectile being 40 meters per second, we need to multiply it by the cosine of the angle at which the rock is launched, 50 degrees. This will give the horizontal velocity. In order to solve for the vertical velocity, the velocity of the projectile, 40 meters per second, is multiplied by the sine of 50 degrees to get the vertical component of the velocity. This is shown by the two equations below. Next, it is necessary to find the time it takes for the rock to reach the cliff, from which the satchel will be dropped. To do this, we use the horizontal velocity and how far the cliff is from the catapult. For the units to cancel out and give the unit of seconds, we need to divide the distance from the cliff by the velocity. We end up getting 2.18 seconds. The next step that is needed is to find out where on the cliff the rock hits when it reaches the wall. Using the equation on the right, we'll do this. The variables that are defined below the equation are substituted into the equation and solved. 43.4 meters ends up to be the height at which the rock will eventually hit the cliff. Now, in order to solve for the time that it takes the satchel to fall to the height we solved for in the previous step, it is necessary to know the distance that the satchel falls to reach the rock. So, to find this, the total height of the cliff, 80 meters, and the calculated distance of 43.4 meters are used. We subtract 43.3 meters from 80 meters, and we get 36.6 meters. So the distance the satchel needs to fall to reach the rock is 36.6 meters. The height that we have calculated in the previous step is used in the following formula in order to calculate how long it takes the satchel with the secret message to fall to the place where the rock hits the cliff. The formula written out on the left is used to solve for the time. The variables are also defined underneath the formula in order to make it a bit clearer. If you look on the right side, it shows the values substituted into the equation and it is solved. The time it takes for the satchel to fall to reach the same height that the rock will hit is 2.73 seconds. Now that we have calculated the time that it takes for the falling satchel to reach the same point on the wall as the rock hits, we need to find out how long after the enemy drops the satchel does the catapult crew need to launch the rock in order for it to hit the satchel. To do this, the time value for the satchel to fall to 36.6 meters and the time for the rock to reach the cliff are used. We subtract 2.18 seconds, which is the time it takes for the rock to reach the cliff, from 2.73 seconds, which is the time it takes for the satchel to fall to the same height as the rock on the wall. The answer is 0.55 seconds. So the catapult crew needs to launch the rock 0.55 seconds after the enemy drops the satchel in order to have the satchel destroyed by the rock.